Some problems in collinearity. Okay, question 2. Maybe press pause and read the question and either look away from the solution or just work through it as a worked example if that's a better way for you to learn. Okay, so what is the highlight here? Probably what I like to do in these situations is draw a diagram, and it doesn't really have to reflect reality. I mean, these points here, 3, 0, 4 and 2, negative 2, 1, I don't know if they're in right relationship to each other, but it doesn't really matter. The numbers are the important thing. Okay, so that's my diagram, and our job is to find the vector OR, which is the midpoint between A and B. So clearly, OR would equal vector A plus half of AB. And we know that A plus AB is equal to B. Therefore, subtracting A from both sides, vector AB is just B minus A. And so that means that OR can now be defined as A plus half of B minus A, because we only are going from the end of vector A, we're only going halfway along vector AB, which is the same as B minus A. The rest is algebraic detail. See if you can reach the solution in the box with the red border. Okay, press pause if you need to, otherwise we're moving on to part B. Okay, part B is quite unremarkable. We're going to follow exactly the same procedure, but the thing about point R now is that it is beyond the vector AB, even though it is collinear with A and B. So it's just on an extended vector from AB. And what's different here? Not much. The fact is, instead of a half AB here, we are going to be interested in 4/3 of AB. See if you can follow the working out. I don't think there's much remarkable happening there. The algebra gets a bit dense and you've got to be a little bit careful around here, but you should end up with 5/3 I minus 8/3 J down the bottom here. Press pause if you need to, otherwise we're moving on to part C. Okay, part C is, again, the only really different thing here is that our scalar, which instead of 4/3 is now negative 1/3, but pictorially I've given a representation of what's going on. This is the vector AB here. Well, negative 1/3 AB is going in the opposite direction and 1/3 of the distance. So we've still got to find OR. And the working out, as I say, is very similar. Press pause if you wish to ensure that you get to this point down here. Okay, question 4. In a triangle OAB, OA is equal to AI and OB is equal to XI plus YI. Let's see B, the midpoint of AB, it says it was supposed to say, but it's cut off. Find OC. Okay, why don't you press pause and have a go at that? And if you don't want to know the solution, don't look at the screen. Alright, so I've turned this into a 3D problem, even though it can be done as 2D. You're only dealing with I's and J's, aren't you? So it's really a 2D problem. But we're doing 3D vectors, so I've included 0 for the K unit vector there and there. Alright, so you'll have no problems, I'm sure, in saying that OC is equal to OA plus half AB. And then all we can do really is define those in rectangular form. That's what we've done here. And that's what we've done there. And now it is a case of expanding everything and seeing what's inside. It gets very messy, but hopefully you'll be able to arrive at the bottom line here. The only thing you could do there, I guess, is factorise in terms of a half. So your final answer could be a half, bracket, A plus XI minus yj in other brackets. And that's the end of this video. Oh no, it's not. We've got one more part, haven't we? Part B. Deduce by vector method the relationship between x, y and a if the perpendicular, so that's cut out there. It was meant to say deduce by vector method the relationship between x, y and a if the vector OC is perpendicular to AB. Press pause and then I'll display the solution. So given that apparently vector OC is perpendicular to AB, perhaps the diagram you see there would be a better representation. Anyway, we know if two vectors are perpendicular, their dot product will equal 0. So that explains that statement there. I've just rewritten the vectors OC and AB for the sake of convenience. So all we've got to do is see what happens when we find the dot product, and what you'll find is the following here, and that x squared plus y squared is equal to a squared. So that's the relationship between a, x and y. That's the end of this video.